Hey guys, am I audible? I think only Pooja and two people have joined. Let me ping the group. Okay, so Narendran and Pooja, if you have any questions, right, you can ask with the previous sessions. Meanwhile, I'll ping in the group for others to join. Like you can ask questions if you're facing any issues, like for any concept or anything, right, or implementing or related to this, like whatever you want to ask. Okay, so guys, let us continue. I think no one else is joining. I already dropped a message. Okay, so give me a second. That's why I'm sharing my screen. I hope that is visible. Okay, so today we'll cover a couple of important things again in JavaScript, and then we can move to DOM manipulation. That basically means that how you can manipulate the HTML and CSS using JavaScript. So we'll do that probably tomorrow, right? And after that, we can start with React, right? So let's see if the next week or next to next week. Okay, so let's continue with this first. Okay, so let's have this page and let's create index.js. Okay, so guys, we know that everything, right? That how JavaScript executes gets executed behind the scenes, right? All the execution context, everything, then it gets deleted, right? All those stuff we already know. So what I'll do is I'll write a question now and let me know like what will be the output. Okay. So I'll create a function and we can say create counter, and we can say let count to be 0, and I can say return function, and here I'll say count plus plus, and then I'll say console.log count. It's a normal function, right? And first of all, if I call this create counter, what will be the output, guys? What it is actually returning?
function.
Yeah, so we can say const counter. So this counter will store the reference of the function. So what we can do is we can call that function as well, and you can call it how many times you want. So guys, what do you think would be the output of this code? Think carefully, right? For the as far the knowledge that we have, what do you think would be the output of this code? Or will it throw any error or will it give any output? What happened? Will it be throwing any error or will it be giving any output? What do you think? Pooja is saying 1 and 2, Disha is saying 0, 1, 2, 1, 2, 3. Okay, Banner is saying error. So, guys, why are you saying that it will throw the error? And why you're saying that it will give the output? What is the reason?
Let is like scope is different, right? It will end outside that function. So once we call that, let account will not exist, so it will be undefined.
Okay, so you are thinking like as far as we know that the execution context of that function will be deleted, right?
Yeah.
Okay. And Diksha and Pooja, why you are giving saying the output?
Let variable is having functional scope.
Uh, no, I think Pooja is correct. It's due to this concept called as closure. But as far as we know that, what would happen is, since we know that all the execution context gets deleted, right? So that's why this create counters execution context would have deleted, and when this function's execution context would have created, then there is no count, right? So let me tell you what actually happens now, because see, the pattern that we are writing here is different. We have not seen this pattern before, and this pattern opens up a lot of possibilities for JavaScript functional programming, guys, right? So let us see that how the output will come, and let us first see the output. So count is 0 first, and if you see, it is only 1 and 2, so no 1 2 3, right? Okay, so let's go here. Cool. So guys, we know all those headache, right? So what will be the first thing that will happen? Can anyone tell me? We have a global execution context. Memory, code, and what will happen here? Okay, so guys, what is the first thing that is gonna happen? We have create counter. It will copy the whole function. Like the whole function reference would be there. And then we have this counter variable that would be undefined for now. And the memory part job is done. So what will be the first line that will get executed?
Create counter function.
Okay. So now what is happening? We have this create counter, and this create counter function is getting called. And again, what will happen? Its execution context will be created. So we are inside the create count, guys, and we know that okay, I'm skipping the undefined part. We know that the count would be 0 here. And then what will happen? Then what will happen?
Function also will be stored in memory.
Yeah, so it is returning a function, right? So this whole function is getting returned to where? This whole function is getting returned here. Is it making sense? So now it will not be undefined. It will be the whole function block. Up till here, everyone is clear, right?
Yes.
Okay. So whenever a function is inside a function, guys, what happens is not only this will go, okay, not only this function would go, but whenever you are returning something, along with that, it takes some something with it. It's like a bag. You can consider it to be a backpack, right? Let's say if you are going to school, if a student is going to school or a college, then they are keeping a bag, and the bag has all the things that it requires. So when a function is returned from a function, then what happens? Not only this part goes, but it takes kind of backpack, you can say, or some kind of uh, box with it, and you can call it as closure. So this box is also closure, this concept is also closure. So along with this, it will take all of its variable environment. So variable environment, you know guys, right? Its own scope and its parent scope's variable as well. So it will take all these things, right? It will take all these things and it will put that variable environment, that is the memory, inside its backpack, and that is nothing but the concept of closure. So when this, so this has the count of 0 inside that, because not only count of 0, whatever the variables, functions, anything that you will put will come inside the variable environment. So now when you returned it, its execution context got deleted, and then when you call, what is happening to this? Yeah, so now when you call the counter, its own execution context happens. And again we have two parts. And when we go inside this, it sees that okay, we are doing count plus plus. Now guys, is count present anywhere? Is it present in its own memory? No. But it is present inside the backpack or the closure it formed when it was returned. So the count is not present here, but the count is present here. So when it discount plus plus in the console, we saw 1 as the output, and the same procedure happens twice because we have another counter. And at that time, guys, the counter was 0 here because we are using the same counter. We are using the same count. So initially count was 0. Initially count was 0. Then it switched to 1. Right? So count was 0, then it printed 1. So the memory will also take 1. The memory will also take 1. Now we call the counter again. I am putting it outside. We call the counter again. And again, same thing, guys. So we call it again and the same thing. Now at this point, what is the value of the count? It's not there in its memory, but is it there in its backpack or closure? Yes. But what is the current value, guys? What is the current value? It's 1. So it prints 2 as the output. Now, why this is a very, very powerful concept? Because you see that the data is getting persisted throughout the function calls. Is it making sense, guys? The data is getting persisted throughout the function calls, even though the execution context are deleted. Guys, any questions here?
Why we didn't assign memory for this function inside this create counter execution context?
Where this memory is there, na count.
No, in this create counter function execution inside memory component.
So here, are we declaring any variable?
No, but function is there after return.
Yeah, so this function we put na here, create counter in the memory, or you can put it here also. That's fine.
Oh, no, I'm asking like it will be assigned memory or not.
Which function? This function?
Yes, inside this create context execution memory context.
Yes, yes, it will be there.
Oh,
But it's an anonymous function, na, so there is no name.
okay. Okay, thank you.
Okay. Any other questions, guys? So let us see that in Chrome DevTools as well. So let us visualize what we have seen. Okay. So what I'll do is, if you go here and let's put some debuggers. Okay, let's put one here before calling this counter for the first time. Right. So let's put one during the calling. So let me refresh. So initially, guys, before even this counter is called, we can see that we have the global execution context created, and the counter is pointing to this function. It is pointing to this function, that is this function, right? And you can see in the scopes we have something called as closure, and this closure is pointing to what? It's pointing to the count, that is 0. So even though there is only one execution context, this create counters execution context is deleted. You can see that in the memory we have the closure, and the closure, this function forms, so the inner functions forms with the outer functions variable environment, and that is called as closure. So this concept is also closure, and this backpack or this box you see, it's also named as closure. Is it making sense now? Now if I step into the function call, you will see we do count plus plus, right? So now we did console, that means this line has executed, and you can see in the closure we have count as 1. That's why you see 1 is the output. Now again, if we go and you will see next function call, in the next function call, again you can see that we are at this point, and when we go to next, the console, the count in the closure becomes 2. So the data is persisted, guys. This is very very important concept. The data is persisted throughout the function execution calls. Guys, is it making sense now, everyone? Waiting for a response. Let me know if you have any questions here. Guys, it is making sense. Diksha, Pooja, Benazir.
Yes.
Okay. Okay, so what is closure, guys? Closure is nothing but it's a combination of function and its lexical environment. When you say lexical environment, that means the scope where it was defined. That means it's variable environment, right? And you can say lexical means going up to the global scope, right? And very, very simple terms, the closure gives a function persistent memory access to variables, or you can say persistent access to variables from where it was created. Remember this, guys, from where it was created, not from where it was called. So things are different here, right? Where it was created.
Sahil, can you please explain this once again, the last concept?
Which one?
The closure is a function which gives persistent access, this thing.
So this is what we meant by this count, right? Even though the execution context was deleted for all the cases, ultimately the count, the variable was persistent across. Persistent means the same instance was going, right? That is why we were able to do it from 0 to 1 to 2.
Okay.
That is the major point, right? Otherwise, what will happen? If the execution context gets deleted, the variables get deleted and recreated from scratch.
Yes.
So this is only possible with the help of closure when you have a function inside a function.
Okay.
So that's the idea.
Okay. Thanks.
Yeah. Okay, so let's take one more example and see it's a pattern of calling, right? So what we can do is we can say const a to be 10, and let's say function outer, let's say const b to be 20, let's say function inner. So what do you think, guys? Any error, or do we get the output? What is happening here? Yeah.
Will get output.
Okay. And what will you like? What will be the your response? Why do we get the output?
Like outer first one will give inner function and then we are calling inner function for second one. So it
Okay.
is same like we did earlier. Like we are storing first we are storing in variable, but here we are directly calling.
Okay. Yeah, you can do that. So what it is doing is, see, the thing why I've written here is because it will have access to A as well. Why? Because that's what lexical environment is. It's variable environment plus the outer scope. So it's memory plus the outer scope up till the global scope, right? So let's see that in action. But we know that the output is 10, 20, and 30, right? And let's go here. Let's put the point here. So when we are accessing console.log A, B, and C, up till then, we have the closure with the outer function. So that's why a lot of people memorize it in this way, that the inner function creates or forms a closure with the outer function, right? So you can see there we have B and it has access to A as well. So C is its local memory, closure is its C outer with the outer memory, and then it has the access to the global memory as well. So that's why we get the output as, like, we get all of the output and we don't get any error. Okay. So one more important interview question that we can do now is, since we now have the idea, so someone might ask you that, okay, you want to have a pattern. So interviewer might ask, okay, can you create a function or can you create the code that basically takes this arguments and the output would be 5. So when you see this calling behavior, what is the first thing that will come to your mind?
Could you please repeat your question?
The question is, you have to create the function or the pattern. When you call this, it returns 5. So guys, have we seen this type of pattern before?
In closer only we can call like this.
Yeah. So this type of pattern we have seen, right?
Yes.
So if you see, this will be the first execution. right?
Yes.
So this should print out 3, and then the function would remain like this, should print out 2, then the function would remain like this, should print out 1. So ultimately, how many functions, guys? Total, how many functions?
There will be only one function where the arguments will be chained.
Why one function?
Like
One
the
function has only one parenthesis, right? You see this pattern? Just now you have seen. How many functions were there? 2 functions, right?
Mhm.
So when we have 3, how many functions will there be?
4.
No, 3 only, right? Why 4?
Okay.
So see, basically what they're saying is you have to write in this pattern. So we know that we have, let's say, function add, and this function add will take a. So when you call this function, it would be something like this, right?
Yes.
But what we are doing here, we want this pattern. So this pattern, how it will occur? When we return a function that takes another argument, right? And this would become this pattern. Getting my point? We want another function. So it will return another function that would take C, and this becomes 3. And then we can say return A plus B plus C. Is it making sense? So when you see this calling behavior, it will be 6. Yeah, sorry, it was 6. So this is the pattern that is frequently asked in the interviews. But since you know the closure concept, since you know the calling of the behavior of the function, it becomes simple to implement. Is it making sense, guys? This part is clear.
Yes.
Everyone, right? So this particular type of pattern is heavily used in functional composition, the Redux libraries, the Lodash libraries that we use for JavaScript, right? So this is a very, very important feature. That's why we ask. That's why these things are asked in interviews a lot. Now to level the things up, let's say now interviewer will tell you that okay, now create a function that would take any number of arguments like this. Okay, so it can be any number of arguments, 1 2 3 4, not only this much, but it can be anything. So you have to give output for all these things. That function should give the output for all these things. So this is the question now, and what would be your approach, guys?
will be 543
543 what?
functions.
So you don't have to create separately. You have to create a single function that would take up all these cases. What happened? If we can find a length of the arguments, then we can compare with the current scheme calling the same function. Yeah, so I think Pooja is correct here. Okay, so again, guys, this type of pattern we have seen, but now we don't know where it will stop, right? So we kind of want to stop the recursion. It's like a recursion, right? We want to stop the recursion based on some base condition, based on the input. So that's why we'll use recursion, right? Because we don't know, right, how much what would be the length of the arguments or how many arguments. So we have to take care of any number of arguments. So we can do that recursively. So this is pretty simple, guys. What we can do is we can say function add. It will take any argument a, and we know that, see, first what we do in recursive solution, right? What we do in recursive solution is we take the minimum possible case. And that I think you guys have already covered, right? So minimum possible case would be this. That means we can take this example and we can take this example. So this example we knew. This particular example we knew, right? So we can say return function b, and that's it. Now we can say const sum to b, or yeah, similar to that, we can do that, right? So this is the basic part that we know for this particular case, right? And for this particular case, there is no b, there is only a. So the very first basic condition could be that if there is no b for this case, if there is no b, guys, then what will be the output? If there is no b, then what will be the output?
A plus B, return A plus B.
No, if there is no b, then the output would be a only, right? Here, the last case. Getting my point? Else we can return a plus b. Simple. We can say add, we can say a plus b. So for this case, for base condition we have handled, if there is no b, it will return whatever the new a is, right? And then again, what it happens is, if you look at in this way, let's take this example. So this will transition to what? Okay, let's take smaller example. So we have 1 and 2, right? The next output for this code will become, so we have 1 and we have 2. So we have 1 and 2 both, right? So it becomes add of 3. Now the same recursive function is called again. Now we have a, that is 3, and we have b, that is nothing. So if there is no b, it will return a. So the base condition arises and the output we get is 3. Is it making sense, guys? Now, so we are combining a plus b and we are reducing, right? This particular function calls will form to this function call, and ultimately we land up to the base case. Okay, so let's try this out and we should see the output 10, 7, 3 and 1. So is this part clear, or any questions here? Or you can even simplify, right? Which I had just added for our understanding. You can just simplify and we can just made it to just one condition. Can say return if there is b, then add a plus b, otherwise just return a. So this will also give you the same output, and this is the ternary operator that we can use, right? So we are calling, we are combining to a single argument, we are combining to a single argument, we are combining to a single argument, until unless we hit this base case where there is no b, and then we return whatever the a is the output. Guys, it's clear, right? Shall we move ahead?
Yes.
Okay. Yeah, and also you can do some uh memoization or something, right? If you're doing some calculation, you can use some memoization or anything. Or maybe we can just create a basic you can say encapsulation or private variables, right? That also you can create using oops, but that is the same concept, but you can do that. For example, we can say function create counter, and this function, let's say let count to be 0, and we can return an object, and we can say increment. Now this is also a function, guys, right? This is also a function. So we know that it will form a closure. Sorry, this would be you can say plus plus count or count plus plus. Okay, but this is a arrow function, so it will form a closure, right? Then similarly we can do for decrement. Similarly we can say get count to be just return or give me the value of count. So I can say const counter to be create counter, and now we can use that. I can say console.log counter dot increment. We can increment it how many times we want. We can say counter dot get count, and we can say counter dot count. So if you see this increment should do, okay, it should be decrement. So increment would do 1 and then 2, right? 1 and then 2, and then we get count, that is the updated one, that is 2, right? But are we getting anything here? Are we getting anything here? No, this is undefined. That means this particular part is a private variable, so you cannot access that directly. So you can create this hidden, right, data privacy or encapsulation kind of things using what do we have, this closure. Okay. Okay, all right, guys. I think that's it from the closures part. So what we can do now is, okay, so let's also talk about oops concept now. Okay, so can anyone tell me, guys, what do you understand by oops concept? I think you all guys already have studied it, right? So there are two types of patterns. Okay, the first one that we saw was functional programming paradigm. right? That is really powerful in JavaScript. And then we have oops based principle, right, where you use this classes and anything. So why do we have this oops important, guys? Because there are a few cases, important cases. Let's say you are creating a game and you have a users in the game, right? And users will have those functionalities. So function associated with their data is nothing but oops, or you can say object oriented programming. That is the idea, guys, because the functionality and data are bundled together, so you can just access them rather than just using basic function calls. Because let's say you have 100 users, and if you're using the same function and calling them at multiple places, right, then it will be confusing, because that function is not bound to its data, but then you are just calling the function and passing data as the arguments. So that's why we have oops, and again you get all those things, right? Encapsulation, abstraction, all these things, prototype, inheritance, right? But in JavaScript, guys, everything is an object, so there is not we have a class syntax, but it's really not the class, but there are a lot of things that happens behind the scenes. Okay, so let's say, guys, we have a game, and in the game we have, let's say, users. So how would you is there any data structure, guys, where you can link the data with the functionality in JavaScript? Guys, what is the data structure that we have? That we can in JavaScript, that we can have a data and a functionality inside it. What is that?
Uh,
Object, right? So let's say that we have users coming into the game. So tell me, we create objects, how we create it like this. So let's say we say user one, and we say that, okay, the name is, let's say, John. Let's say the score is 10, and we want to increment the score of that particular user, so we can have a function, and that function just says, now how do you get the score, guys? So for now, remember, there is this special keyword, because you cannot have user one here, right? Because it does not have access to that. But if you say this, that this points to the object, in this case that is user, and from there you can say this dot score. So it's a special keyword. We will check out its functionalities in different behaviors, but for now, this will point to the object. So when we say this dot score plus plus, it will go to the score and it will add. And similarly, we can go here, we can say user 2, let's say Peter, the score is, let's say, 5, and the increment. Now what is the problem, guys, with this approach? If your application has two users, it will work fine.
it will be repetition in case we have like 10, 100 users, that sort of.
Exactly. So what we can do, the next step. If we want to, if this is the problem, what could be the solution for it? The basic solution. Where can we put this logic into? So we just have to use it, reuse it.
We can create a function.
Exactly. So we can say that we have some kind of factory functions. That is one of the solution to this. So what can be done here? We can say function create user, and it will take the name, it will take the score, and we can say return name, score, and increment. So now how do we create them? We can say const user1 to be create user, and 5. Right? So this is easy to reuse. But tell me one thing, guys, is it efficient? Think about it. Is it efficient, or is there any problem associated with this particular code? What happened? Efficient or not efficient? Very simple question.
Instead of taking a blind guess, I will say like will like to know from you.
So why a blind guess? Let's say we have 1 million users. Don't take a blind guess. See the code and like observe. Have the answer.
So for this scenario, we'll be creating like we have to execute okay, like create 1 million functions for these different users. I think in that scenario it will be non-efficient.
See, function creation is fine, right? So read the code one like out loud. What we are doing inside the function. Yeah, you can unmute and read it out loud.
It is basically returning an object over here.
Yeah. And inside that object,
Inside that object, like there are like two properties, name, score, and and the like third property is a function which is taking reference of score, current score.
okay. So for 1 million users, okay, we know that for 1 million, the name and score would be different, right?
Mhm.
But what is the same thing that is we are attaching to those 1 million function calls?
Increment function and
Yeah, it is the same function, right? It's literally the same function that we are attaching 1 million copies to it.
okay,
So this is inefficient, right?
okay,
Getting this point, everyone?
yes.
Others?
Yes.
So the thing is that, see, we function calling is fine. We know that we call a function because we are reusing or we want to do something, right? Multiple times. So the thing is that, okay, name and score are different, but increment is the same, exact same copy, guys. For 1 million users, how many copies we are attaching?
1 million.
Yeah, and that is inefficient. So what should be the ideal scenario? Forget about JavaScript, anything, just let's focus on the problem. The problem is we are attaching 1 million copies. Ideally there should be how many copies?
One copy.
Exactly. So ideally the problem is for 1 million users it will create 1 million copies. But this we are only talking about increment, guys. Imagine that in the game you have a lot of functions, similar functions like decrement score, get score, whatnot, right? And those copies would you be creating, right, that many times? So for x million users will be x million copies. So ideally there should be one copy. Now if you have seen, guys, something, I think you have seen this prototype, right? So if we go here, let's go to console, and we see that we have an empty array, and in this empty array I can have another array that has values 1, 2 and 3, and you can see each array has access to this methods, right? That is its prototype. It has these methods. So you can use at, map, push, pop, all these methods. This we discussed, right, last time, that it has all these methods. Do you guys remember? So it's the core pattern or core part of JavaScript. You can see that no matter how many arrays you create, no matter how many arrays you create, it has the link to the same prototype where you can reuse those functions and objects. So they are not separate copies. It's kind of a link to that prototype, right? So similar thing we can do here as well. Right. So what if the functionality could be shared, right? So we can have another object, let's say function, and let's say that user has to use those methods, and we can have the method, let's say increment. So sorry, const. And again, guys, we will represent this keyword, this dot score plus plus. And let's have another method, let's say login, and we can say console.log this dot name logged in. So this is something that we need to share. We need to share among different users, right? So what we will do is, first of all, we'll create this create user. Okay, it will take name and score, and we can do something like we can say const user to be an object, and we can say user dot name to be name, user dot score to be score. That is coming from the parameters, and then we can simplify, we can say return user, right? Now it turns out, guys, in basically JavaScript, you can create an empty object using multiple ways, right? And one of the way is object dot create, right? It creates a new object. So if you want to see that, we can say object dot create, and it would give you the new object, right? But what is the beauty of this method is that I can go here, I can say rather than this directly, I can say object dot create, and I will pass this user method's object here. This is the very important step, and this particular part is called as we are using the shared behavior, that is the prototype, right? Or there is also called as this underscore proto link. So this is the linkage that we are using. So it is doing all that automatically. You can also manually change that link, but here we are doing that automatically. So this object dot create is a special method that creates a new object here. For example, I'll go here and I say console dot log user. So what it is doing, it is creating, it is creating an empty object, but it adds this object as its prototype. So we have user 1, user 2, and it's better that we put the name here. So this is John, and we can say Peter. So we have two objects. Now the object would have a prototype, and this prototype would be this functions that we have added. It also has the shared function, that is the next part of the linkage. So now you can see, guys, the functions are shared, they are a single copy, but the reference has been created. If you look at visually, if you create the diagram, the prototype, the linkage, it's just like this is kept somewhere, right? Let me tell you. So for example, we have user 1, we have user 2, and it has its own name and score, right? It has its own name and score. But here we have created a reference object, or you can say link, and you can call this as prototype, and the linkage that happens is called as underscore proto, and or there's a technical term that is used here, that is this part, this. So this prototype and this prototype is different, guys, right? This proto and this prototype are same. Now there is more to it. We'll cover that probably I think tomorrow, because then it will be a lot of the things, right? And if other people also join, then we can cover this in more depth. But this linkage to this prototype that is nothing but our user methods, where we have increment and login. So it is kind of shared, and that's how this particular thing is something that you can use, right? Again, this is not in production like it was used earlier. Now we have a lot of more things into picture, right? But this is one of the important solutions to the above method, because now how many copies are there for the functionality, guys? Only one, and each and every user is kind of sharing, it's kind of linking to that particular prototype. Is it making sense? I know these terms are new to you, right? But the only thing is happening is now we are not creating million copies, it is just one copy for million users. And we have done nothing new, right? It is just the same concept that JavaScript was using for array methods and object methods. For example, if we have an array, JavaScript automatically assigns or provides that linkage to any array, even if the empty array is there, right? It assigns all these things. So it's a shared uh, object, you can say, where you can pull the values, the functions, and you can use them, right? Similarly to the object also, it assigns some prototype. So we have object methods, all these things. Similarly to the function also, it assigns something, right? So to the function also, it assigns something. So all these things are there, and this concept only we have used for our case, right? And so this is the very very important line that is doing that linkage part. Is it making sense, guys, everyone? If you see the output, you'll get the output, right? We saw that in the console. Guys, is it making sense? Any questions here? Guys, are you there? Is it clear? Only to Akshay. What about others? Okay. So that linkage, guys, is happening here. But again, what do you think could be the problem with this approach? Guys, what is the problem of this approach? Guys, what do you think is the problem with this approach? So that prototype reference would change, na, Akshay? It's a link. You can cut that link, and that link can point to something other, right? So that reference might change. Okay. So guys, the problem with this is that okay, this works fine and everything, right? But still, you see some redundancy here, right? And what is the redundancy? What is the redundancy here? Again, it feels like some of the things are being not following the dry principle, right? That you are every time for 1 million users or any million users, you are again creating an empty object, you are manually doing the linkage, you are assigning the parameters, and that's how it's working, right? So what if you can automate some part of it, right? So the JavaScript creators realize this, and now the pattern is different. So what we can do is they have introduced the new keyword, so you can see there is still some redundancy left, like creating a user and assigning the values, the key value pairs, all those things. So though they realized this particular problem, and what they did was, okay, then you can use something called as new keyword. So that new keyword came into picture in JavaScript, right? And what this new keyword does, it does a lot of things behind the scenes. right? It automatically creates an object and returns the object. So what you have to do, you don't have to do anything, you just have to add a new keyword to a function call. So we can say function, and we can say user, it can take name and it can take score, and we can just say this dot name, and we can say this dot name to be name, and we can say this dot score to be score. Now how do you call it, guys? You just say const user1 and you say new keyword, and we call this function. So it's a new pattern that we have. Ultimately it's the create user function only, right? You can just make it bigger, the first letter, because then it's just like the developers will know that we have a new keyword. So when you say new keyword, guys, see, when you attach the new keyword to it, what happens? It does two things, right? It creates the empty object. For example, if I go and say console.log this, you will see that it will create an empty object, right? And it will auto create the empty object. It will automatically create an empty object. Then in that empty object, we are saying this dot name to be name, this dot score to be score, and then we are not returning anything. It is automatically returning that object. How do we know that? We can say user1, and user1 you can see is that returned object where we have name as John and we have score as 10. So again, that redundancy of creating a user, assigning them values, and then returning the user is being automated by this new keyword, guys. And that is how this new keyword was launched in JavaScript. Now a lot of people directly jump to the new keyword, and then they do not know what is happening behind the scenes, right? So ultimately this was the solution, and this solution was enhanced to this solution, right? So this new keyword is doing that job. But now the question comes, guys, if the new keyword is automating this task for us, then how do we create this link? That is the question, right? That is the question. So we'll cover that tomorrow, guys, because I want others also to understand this. So we will have a revisit to this particular part. So I want you to think, right, that new keyword is doing the job, we know that. But now this keyword is pointing to the new object, right, that is being created. So this new keyword is automatically creating that, and it assigns that object to this, right? And then it returns the object. So how do we create that link, or where do we put this shared methods? That is the question, right? Because here we were manually doing that. Here we were manually doing that. But now the question is, since it is automatically done, how we will create a link, or how we will put the shared methods? So that is the question, guys. Okay, and I think it would be better if I remove this part here, right? And now since we do not have the option to manually create it, we'll have to think of something, right? So any questions up till here? I know that we have covered a lot of new concepts today, but it's fine. We'll get more sense tomorrow, because once you get the clarity, right, then you don't have to revisit these concepts again and again. So if I revisit, guys, we were talking about a problem statement, where we have a game and then we have list of users. So this was one way. This was not scalable, so we created a reusable factory function. But again, for 1 million users, it was creating 1 million copies. Ideally, we should have just one copy. So what is the functionality could be shared, right? So for sharing that functionality, we created a new object that we want to share, and we create the manual reference link using that object dot create, and that's how we were able to create that reference, and we were able to use that. But again, this solution has some redundancy because we are again manually creating the object, we are manually assigning and returning all those things, right? So that's why the new keyword came into picture. The developers realized that okay, we can create a new keyword that will automate a lot of stuff. So it creates an object, it assigns that object to the this keyword, and it returns the object. So you can see we just have to do this. If you skip the new keyword, then it will not be doing all this stuff, right? So it's always important to use the new keyword because it's the job of the new keyword to automatically create an empty object, assign it to this, and then return the newly created object. Guys, any questions, anyone? Diksha, Benazi, Rakshay, Pooja. We will cover this part, but I would advise you to uh, practice this part, guys. So we have this question, and I want everyone to figure out this answer, guys. Those who are present today. So I've shared the drawing board link in the chat. Okay. Uh, let's cover this again from scratch tomorrow. So we will take up these examples. If you want, I can show you the visualization of the diagrams that we create, right? So I think then it will make more sense. It's all about link. You have to think in pictures, you have to think in that mental model. And once this part is clear, then it's easy, right? Then it's not tough. Okay, so guys, I've shared the code link as well. If you have any questions, you can ask. Otherwise, we can end the session. Okay, thanks, guys. Bye. Take care. Let's meet tomorrow.